Right now, as we speak, there is a supermassive black hole with a mass of 20 million suns barreling through intergalactic space at 2.2 million miles per hour, and it is dragging a trail of newborn stars behind it like a cosmic contrail.
And that's not even the wildest thing the James Webb Space Telescope found this month. Welcome to Things I Know Nothing About. I'm Maya.
And I'm Alex. Today we're doing something a little different. Instead of one topic, we're covering the absolute avalanche of discoveries JWST just dropped. Runaway black holes, the oldest galaxy ever seen, hidden supermassive black holes, organic molecules where nobody expected them. It's a lot.
It's a buffet of cosmic weirdness. Let's start with the headliner. So, this runaway black hole, walk me through what happened.
Okay, so this story actually starts back in 2023. A team led by Peter Van Dockum at Yale was looking at a Hubble image and noticed something strange. There was this thin, bright line extending out from the center of a galaxy, just this long streak, and Van Dockum said, basically, I think we're seeing a very massive black hole that got ejected from its galaxy and is leaving a trail of gas and newborn stars in its wake.
That's a bold claim from a Hubble image.
Very bold, and a lot of people were skeptical. Some researchers argued it could just be an edge on galaxy, a thin galaxy we're seeing from the side. So the team needed confirmation. They turned to JWST.
And JWST delivered.
Oh, it delivered hard. The paper dropped in December 2025, published by Van Dockum and colleagues, and what they found was stunning. At the very tip of the 62 kiloparsec long streak, about 200,000 light years of trail, JWST detected a sharp kinematic discontinuity, a sudden shift of about 600 kilometers per second across just 1 kiloparsec.
In regular words,
In regular words, something slammed into the gas at the front of this streak so hard it created a bow shock, like the sonic boom of a jet, but in space made by a black hole. The velocity modeling gives them a speed of about 954 kilometers per second, or roughly 2.2 million miles per hour, and the whole thing sits at a redshift of 0.96, so we're looking at this from about 7.7 billion light years away.
how does a supermassive black hole even get kicked out of its own galaxy? It's supposed to be the anchor.
Two main ways. The first is gravitational wave recoil. When two galaxies merge, their central black holes eventually spiral toward each other and merge too. In that final moment of merger, they release a burst of gravitational waves, and if that burst is asymmetric, if it's lopsided, the newly merged black hole gets a kick in one direction, like the recoil on a gun.
And if the kick is hard enough,
It exceeds the escape velocity of the galaxy, gone, flying through intergalactic space forever. The second mechanism is a three-body interaction, where three black holes end up in close proximity after multiple mergers, and the gravitational chaos flings one of them out. The Van Dockum team thinks gravitational wave recoil is the more likely explanation here.
and here's what I love, there's actually a counter paper just dropped days ago.
Right. A team led by Jorge Sanchez Almeida published a paper arguing the same JWST data is consistent with an edge on star-forming galaxy. They used BPT diagnostic diagrams, which are standard tools for distinguishing between shocks and star formation, and they say the emission line ratios could go either way.
So this is live science happening in real time. One team says confirmed runaway black hole. Another team says, hold on, could still be a galaxy.
And that's how science works. Van Dockum's team argues the bow shock and the 600 kilometer per second velocity jump they measured are really hard to explain with a simple galaxy. Van Dockum himself admitted their original 2023 Hubble paper got quite a few of the details wrong, but the key interpretation held up. That's real science. You get the big picture right, then spend years refining.
And this might not be the only one.
Not at all. The paper mentions other candidates, including a black hole in the dwarf galaxy manga 12772-1212704, that's offset from the galaxy's center by about a kiloparsec. Looks like it could be drifting out, but Van Dockum's is the only one with a confirmed bow shock so far. If theory is right and these ejections happen regularly after galaxy mergers, intergalactic space could be full of rogue supermassive black holes just cruising through the void. No galaxy, no home, just running.
That is deeply unsettling and deeply cool at the same time. Let's shift gears to something even more mind-bending. The oldest galaxy ever found.
Mom Z14. This one broke my brain a little. JWST captured this galaxy as it appeared just 280 million years after the Big Bang. That's a redshift of 14.44, which is the highest spectroscopically confirmed redshift ever measured. Webb keeps breaking its own record.
What does 280 million years after the Big Bang even mean in context?
The universe is 13.8 billion years old, so this galaxy existed when the universe was about 2% of its current age. It's like looking at a photograph of a person taken 20 minutes after they were born. The universe was barely a thing yet, and somehow this galaxy was already forming stars like crazy.
How big is it?
Tiny, about 240 light years across. For comparison, the Milky Way is roughly 100,000 light years across. So Mom Z14 is like a grain of sand next to a beach ball, but it contains about 100 million solar masses, similar to the Small Magellanic Cloud, one of our satellite galaxies. And it's remarkably bright for something that small and that old.
And the name MOM Z14. What's that about?
It was discovered on May 16, 2025, by a team led by Rohan Naidu using JWST's NIRCam instrument in the Cosmos field. The Z14 refers to its approximate redshift. The galaxy sits in the constellation Sextans, and right now, due to the expansion of the universe, its proper distance from us is about 33.8 billion light years.
Wait, 33.8 billion. But the universe is only 13.8 billion years old.
Great catch. The light traveled 13.5 billion years to reach us, but in that time, space itself has been expanding, so the galaxy has been carried further away. The light we see left when MOM Z14 was much closer. Think of it like running on a treadmill that keeps stretching. You started close, but the ground behind you has been pulled apart,
And this galaxy was forming stars during the reionization era?
right? That's the period when the first stars and galaxies were pumping out enough energetic photons to ionize the neutral hydrogen that filled the universe. MOM Z14 was part of that process, and here's the kicker. The metallicity of this galaxy is higher than current models predict for something that young. It had already enriched itself with heavier elements faster than we thought possible.
Which means our models of early galaxy formation need updating.
Yep. Again, JWST keeps telling us your models are wrong. Fix them. And here's the other thing. MOM Z14 was forming during the reionization era with an almost dust-free interstellar medium. The energetic photons from its star formation were punching out into space and partially ionizing the surrounding environment. This tiny galaxy, 240 light years across, was helping to light up the universe.
A 240 light year galaxy helping to end the cosmic dark ages. That's poetic.
It really is. And MOM Z14 is currently 33.8 billion light years away from us due to expansion. Even though the light only traveled 13.5 billion years, the universe has been stretching the whole time.
Okay, topic 3 hidden black holes. What's the deal?
So we've known for a while that basically every galaxy has a supermassive black hole at its center, but some of these black holes are what astronomers call low-luminosity active galactic nuclei, or LEGNN. They're active but quiet, like an engine idling instead of revving.
And traditionally, astronomers kind of wrote them off.
Pretty much. The assumption was that if a black hole isn't actively gobbling up matter and blasting out jets, it's not doing much. JWST just showed that's completely wrong. Even these quiet black holes are ejecting material, energizing gas, and creating unusually warm molecular hydrogen in their surroundings.
So they're not asleep, they're just whispering.
Whispering loud enough to influence entire galaxies, the JWST observations reveal what are called kinetic feedback processes. The black hole pushes and stirs the galactic gas and dust. It can clear out regions, stopping star formation, or compress gas and trigger bursts of new stars. The excitation temperatures of molecular hydrogen in these LAGN galaxies are systematically higher than in other galaxies,
And this matters because
it changes our understanding of galaxy evolution. These quiet black holes aren't passive, they're actively shaping their galaxies, even in idle mode. It means the engine is always on. There's no off switch.
all right, last discovery organic molecules where they shouldn't be.
This one has implications for astrobiology. A team led by Ismael Garcia Bernete used JWST to study a galaxy called IRAS 072510248. It's an ultra-luminous infrared galaxy, meaning its core is wrapped in such thick dust that almost no visible light escapes, but infrared punches through.
And what did they find in there?
An extraordinary inventory of organic molecules: benzene, methane, acetylene, diacetylene, triacetylene, and for the first time ever outside the Milky Way, they detected the methyl radical CH3. This was published in Nature Astronomy.
The methyl radical is a big deal.
Huge. CH3 is a building block, it's reactive, it's involved in the chemistry that leads to more complex organic compounds. Finding it outside our galaxy, in the nucleus of a dust-choked ultraluminous infrared galaxy, tells us that complex organic chemistry isn't just happening in nice, calm molecular clouds, it's happening in some of the most extreme environments in the universe.
And the abundances were higher than models predicted.
Way higher. Garcia Bernete said they found unexpected chemical complexity with abundances far higher than predicted by current theoretical models. They think cosmic rays are processing carbonaceous grains and polycyclic aromatic hydrocarbons, basically smashing apart carbon-rich dust and creating all these smaller organic molecules.
So cosmic rays are essentially doing chemistry like a cosmic blender.
A cosmic blender. I love that, yes. And the spectrum showed gas phase molecules alongside solid ices and dust grains, all layered around the nucleus. Hot core in the center, warm molecular zone around that, then a cold outer envelope with frozen water and other ices, like a cosmic onion of increasingly complex chemistry.
And this was published in Nature Astronomy.
Right, by Garcia Bernete and colleagues. They used both the NIR spec and MIRI instruments on JWST, covering wavelengths from 3 to 28 microns. That full infrared range let them see chemical fingerprints from both warm gas phase molecules and cold solid phase ices in the same observation. No other telescope could do that.
So JWST is basically a chemistry lab now, in addition to everything else.
It's a chemistry lab, a time machine, a black hole detector, and apparently a debate starter all in one.
So let me put this all together. In the span of about a month, JWST has confirmed a runaway black hole with the mass of 20 million suns, found the oldest galaxy ever seen at 280 million years after the Big Bang, shown us that quiet black holes are secretly running their galaxies, and discovered an organic chemistry lab hiding inside a dust-wrapped galaxy.
And it's only February.
This telescope just keeps delivering. Every single month, it's like, here's 4 things that rewrite textbooks.
The thing that gets me is the range from the first moments of the universe with MOM Z14 to the violent dynamics of black hole ejections to the quiet influence of hidden engines to the building blocks of organic chemistry. One telescope, 1 month.
If you're listening and you want to dig deeper, we'll have all the papers and sources linked in the description. Thank you for spending your time with us.
And remember, the universe is not just bigger than you think, it's weirder than you think. See you next time on Things I Know Nothing About.